Welcome to the Spark Advanced Programming. Let us understand how we can improve performance of our Spark applications using persistence or caching. Recollect that RDDs are lazily evaluated. Whenever an action is executed on an RDD, all of the RDDs on which it depends upon are also evaluated. Which means, if an action on an RDD in this graph is being called twice, the same computation could happen twice. Also, we may wish to use the same RDD multiple times. So to avoid recomputation of an RDD, we can cache or persist it using the function provided on RDD. If a node that has data persisted on it fails, Spark will recompute the lost partitions of the data when needed. We can also replicate our data on multiple nodes if we want to be able to handle node failures without slowdown. Let us take a look at the following code in order to understand the caching. Create an RDD of numbers from 1 to 100,000 with 50 partitions. Now, say we are creating another RDD with partitions by summing up the values of each partition of num's RDD. We first created a function mySum which sums up the values of an iterator and then returns the sum as a single value iterator. This function mySum is being called using map partitions on nums. Now, say we have created another RDD, partition 1, from partitions RDD by increasing each value by 1 using a map. Every time we are going to call an action on partitions 1 RDD, partitions RDD is going to be called. If partitions 1 is going to be used frequently, it will be inefficient. In such circumstances, we can cache partitions 1 RDD. We can persist an RDD using a method persist. This method needs an instance of storage label as argument. The storage label specifies how should the RDD be persisted, in memory or on disk, for example. If we do not provide any argument, it saves in memory only. Now, let's try to persist in memory and disk both. But before repersisting, we need to unpersist. For that, we can use a method unpersist. Now, let's import a class called storage label. Then, call method persist with the storage label memory and disk. If the RDD does not fit into the memory, it would spill over to the disk. Let's check using getStorageLabel, and you can see that it is same as storage label dot memory underscore and underscore disk.